number 44. Assuming a fixed amount of gas, complete the following table. So we're given P1, V1, and T1, and we're looking for P2 or V2 or T2. So this is a combined gas law problem. When the only constant variable is the moles, and the other ones can change, that's combined gas law. And here's the mathematical form of the combined gas law. And we have to do 3 problems. In the first one, we're looking for P2, the second one V2, and the third one T2. And we also have to do some conversions here. In the first one, the 2 volume units are the same. The temperatures, of course, got to be in kelvins, and they are for the first one. So the first one's going to be easy. The second one, the pressure units are different, so we got to make them the same. We got to convert one of them. And here we're given a temperature in Celsius, so we got to get this over to Kelvin. And the third one, the pressure units are the same, but this temperature is in Celsius, so we got to get that to Kelvin, and these volumes are different, so we got to convert one of them to match the other. So several conversions are going to be needed before solving the problem. Okay, let's start with A. A is going to be easy because no conversions are necessary. The liters matches the liters, and these are both in Kelvin. So A, solving for P2. P2 is P1 V1 times T2 over T1 V2. If you solve for P2, you move the other 2 to the other side. This is what you get. Okay, now substituting in for all of these, everything that you're given, you can see the liters cancels the liters, kelvins cancels the Kelvin, you're left with atmosphere, and the math gives you 0.17675, which rounds to 0.18 atmosphere. For part B, we're looking for V2, and solving the equation for V2, this is what you have. And in this one, we need to convert this to Kelvin. We need to convert T2 to Kelvin, and we got to match up the pressure units. So let's just convert P1 over to atmosphere. So let's fix P1 and T2. First, T2, you take that 0 Celsius, add 273, that's 273 Kelvin. And then to turn P1 into atmosphere, 735 millimeters of mercury times 1 atmosphere over 760 millimeters of mercury, that's the conversion factor. To get the atmosphere, the units cancel and you're left with atmosphere and 0.9671 atmosphere. So substituting these in now for T2 and P1. So here's T2 and P1 along with the others that you're given in the problem. All the units are canceling except for the new volume unit, so that's in liters. And the math gives you 0.9665 liters, which rounds to 0.97 liters. And the last one, we're looking for T2, and we got to do some conversions. It looks like the liter unit or the volume units need to match up. So we'll turn this into liters, and it looks like this Celsius needs to be fixed as well. So we got to convert this to Kelvin. Okay, and we're solving for T2, so solving the combined gas law for T2, here it is. And we got to fix the temperature, T1, get it over to Kelvin. So take that negative 120 Celsius plus 273, that's 153 Kelvin. And then V1 is 230 milliliters. Getting that over to liters is 0.23 liters. So plugging T1 and V1 in, right here, and then the other ones, you can see the units are canceling. You're left with Kelvin, and the math gives you 598.6 Kelvin or 600 Kelvin, 2 sig fig result right here.